Hey guys, this is Vanderson from MATLAB VFX, and today I'm going to show how I created this epic castle destruction using Houdini and Nuke. We'll go through procedural modeling, RBD simulation, dust effects, and how to composite everything in Nuke for a cinematic look. This project is great if you are learning effects or want to upgrade your reel with destruction shots. And yes, you can access the full project file with Houdini and Nuke scenes using the link below to the download. Let's jump into the breakdown. Here is the Nuke project that I did the compositing for the castle destruction. Let's see each layer passes and see what is happening. First is the castle. The castle itself like a beauty pass with just the RBD simulation destruction. The render here using a texture map with displacement. There are some passes inside here, like ambient occlusion, directional unshadow, direct glossiness, and a shadow pass. I create another shadow pass for the contact of the rocks. I create a emission pass for the fire rocks. This is the emission pass, like the fire reflecting the rocks, the castle. This is another pass, the smoke itself. This is the smoky dust destruction and the fire rocks flying to the castle. I create this layer of clouds, a back layer, just to use the VDB noise in Houdini. This is the back cloud, and this is the front cloud. For the render passes, it's just like this. Just like the 1, 2, 3, 5, 6 passes of render. Let's jump inside Houdini and see how I construct each layer of effects. That's the file project available in the GoRound. You need to install the Side Effects Labs and the QLib. Let's dive inside of each effects and see how I construct that. Let's first dive inside the tower. That's how I organize the file. The first step here is just to create a base. But first, let's see how the result of the project here, the tower, the castle. That's the result of this network. Like 6 castle, like 6 towers and 5 walls. The camera here. That's the target of the 3 strikes. These 2 towers and the wall in the middle. Let's see the steps. First step, we can create the base of the tower. At first I create a tube, UV texturing, match size to the ground, lift a little bit, polyfill the ends, apply the UVs at top and bottom, create some bevel here, and create the group. I create a simple point here, and this point to group wall point, just for reference later. You can see the point here and the base. And I group all the tower, delete the group we don't need, and save. Let's see the second step. The result is here. Just the tube wall with the window frame is made of bricks and the top and some details here. For that I start with just a circle. Let's see this side here. Resample that circle. Create some vex here to organize the normals. Copy some box here to the points, auto UVs, scale the UVs, and polybevel all the geometry. This is that detail from the top. The body here, just the poly extrude the circle, create an insert in the poly extrude again, just grab the points here, keep the points, group delete, add, just to make the construct the spline again, UV texture to the spline, revolve, adjust the scale of the UVs, polyfill top and bottom, create the UVs in the top and the bottom, create a polybevel in the hard edges, reverse the normals, and create the group here. We match the sides from these blocks here corresponding to the circle here, to the floor, and merge back the bricks with the floor. At the other side here, we'll create the tube, unique points, assemble that points, extract the centroids, create another circle here from the points, resample the points just to make 5 points, apply some vex operation here just to increase the height of each point, match the size with the tube, and create some windows here. In the window brick, just a simple circle, transform a little bit, clip again, make a mirror, poly extrude, match the size to center with the word, group out the face, create a poly extrude on the bottom, delete all the groups we don't need. That's the part of the subtraction from the wall. Create a grid here, a match size to create the brick window, transform a little bit, make a boolean, divide to remove the inside edges, fuse the points, resample the edges, convert the edge to line, and create the shape of the window. At the bottom, we clip the bottom, apply the polyframe to organize the normals outwards, and create the attribute up. Clip the top, fuse, sort in Y position, delete the top points, and organize the normals, and merge back again. Convert this to line again, randomize the scale, randomize the position a little bit, and copy some blocks here, just to make the window frame made of bricks. Unpack, make a polybevel, create the automatic UVs, scale the UVs a little bit, create a group, and move back a little bit. That's the frame of the window. And copy some variants here to the original tube. Here, we use that tube again, apply the UV texture, extrude to make the thickness of the wall, make some boolean from the windows subtract, divide to triangulate out the mesh, polybevel the hard edges, divide again the hard edges, adjust the normals, create a group tube, and merge with the windows. Create some random rotation in the Y, merge all back again, and adjust the position with the base. The base original position is here, that's level A, tower level A is here, that's the result. Let's see the result of level 2 tower, almost the same operations, I think that's identical operations, just with a different in the height and the scale of the floor, and these brick decorations here. That's the result. The level C, let's see. The same operations without the floor and the bricks decoration. Another pass here is the crowd, the top of the tower. Let's see from the beginning. Just create a line. This node is not using. Resample that to make more points. Create a profile using VEX. That's the VEX. Remove the inline points we don't need. Convert the line. Sort the points in the Y position. It's doing nothing. Resample the lines. Fuse the lines. The points. Convert the line to connect the one path. Revolve these lines here. Here we create a box. Clip the box in the middle. Create an array, polar array. Adjust the position with the revolve here. Just to make the boolean. That's the boolean. And match the size with another layer of the rotating box. That's a box. Clip, poly bevel, and array. Create another match size here. And subtract again the base. To make like this. Let's adjust the normal for extrusion. Make the extrusion. Fuse the points to clean up. Divide all the edges. Let's disable the UVs here just to see the edges. And here I just extract the borders. Convert the line to connect the path. Fuse the points. We just need the bottom. We don't need the up. Using delete the small parts. Construct the bottom here again using the add. Poly extrude. Adjust the match size with the center of the word. And make an array from the inside points to that cylinder here. Auto V the geometry, like this. I scale the UVs, recompute the normals, fuse the points, poly bevel all the hard edges, divide again to make the triangles where I need, adjust the position in regards of tower level C, adjust the scale of the UVs, delete the groups and attributes we don't need, and make the group. That's the result. The crown, the tower crown. This step 6 is just unify all the elements, save the cache, and make the copies here. 6 copies of towers. Create a tower ID for each tower and match the size to the center of the word. Now we need to create the walls. The result is this, just the 5 walls with the gradient in the bottom to up, a ramp. Import all the towers. Just keep that points made it the first. This guy here have a point below of the tube here. Just keep the points. Connect all the points. Create a rest position here. Convert the line. Carve a little bit. Sorting in X position. And create a poly expand just to extrude a little bit. Create some IDs from the walls using VEX. Move a little bit back. create some normals and up vectors, remove the inline points, and poly extrude all the 2D geometry. Delete the attributes we don't need, move back a little bit, clip the up, polyfill to the clip, and this is a subnet to create the top of the wall. Let's dive inside and see how it is built. Just they split the top of the wall, poly extrude a little bit, create a bound, calc the measure, sort by the measure, keep the smallest primitives, extract the centroid of each primitive, create a line connected for each primitive here, resample the line, and copy some box here, just to make the subtraction from this geometry here. Just poly bevel to make this edge more interesting, create a boolean from that boxes, and attribute transfer for the wall ID. That's the result of the boxes. Adjust the normals, divide to make the brick grid here, apply the UVs, adjust the scale of the UVs, and here just create auto UVs, scale the UVs, and make a boolean here, just to slice the top here. Transfer the wall ID and merge out back the bottom part of the wall and the top decoration here. Fuse and assembly. Create a group of a big wall, and here just create the wall ID for each line, just to create here all these columns here. Create the wall ID, resample inside the for each, just reduce the length of the polygons, create a promote attribute wall ID, just keep the points and copy some box here. This is just a simple box, stretch in Y, group the bottom vertex here, scale to front, create automatic UVs and scale the UVs. Copy to the points, promote the wall ID, and match the size regarding to the walls here. Create a group wall column and merge. Adjust the scale of UVs again, just to match the size from each UVs. Poly bevel the hard edges, divide quads, and divide to triangle all the geometry. Adjust the color and the Y using the labs adjust color, and that's the result of the wall. Let's see the cleanup here, castle cleanup. Just import all the towers, remove the points, the bottom points here, import the wall, merge, sort the primitive by random, connectivity, apply a random by colors, just keep the luminance, go back to the color original, white, and create some groups here using VFX, just to identify the shaders. Delete all the attributes we don't need, like a race, brick type, color, class, copy none, and tower name, and save the tower asset here. That's the asset we are going to break and apply some smoke operations in that. Now we can dive inside the rock geometry. This is just a simple animation. Let's see the tower here. That is just a simple animation of the rocks striking the walls in the tower. Let's see the camera. First strike, second strike in the wall here, and the third strike in that tower here. Let's see how I did. Let's hide the tower. Just a sphere with some mountain. Rest just to avoid the sliding shaders in the rock, and create a spinning rock here in two axes, X and Z. For the first, I create just a trajectory of the points. Let's say with the castle, 3 points trajectory, 1, 2, 3 points here. Resample and subdivide the spline. Carve the animation where I need the path of the point. I need just to grab this point here to instance the rock, spinning rock here. Keep just the point 0. Calculate the trail, the velocity. Randomize the orient. And just copy the rock to the point. I did the same operation for the 3 points. I created the 3 trajectories. You can see here, 3 trajectory points. Let's see the point subdivide. Here. That's the trajectory points with the spinning rocks and the tip. Let's see it from the camera. First strike, second strike, third strike. Just super simple setup. Now let's see the simulation, smoke simulation from the spinning rocks. Let's hide the tower. I just imported all the spinning rocks. Delete all the attributes we don't need. Just freeze the first frame. Create the pyro source for that rock. Create the noise for the density. Let's see the density, the noise here. The noise for the temperature. There's no animation. I extract the transform from the rocks and I copy the spinning rock, the spinning source of the pyro. Here. Calculate the trail just to make the copies. And I create the frame range where I need to start and finish the rock, because the spinning rock is coming from outside the camera. I don't need to make the trail all along outside the camera. I just need the trail to be started 1 or 2 frames before the rock enter the camera, like this. For example, you can see here. Just push the camera a little bit. 2 frames before, there's no rock. And the rock appears near to the edge of the frame. And start the simulation and collide with the tower. Just compute the trail. Make some point velocity here and convert this to rasterize VDB using temperature, density, and velocity. Here are the 3 caches, each one for each rock. Let's see the result of the first trail. Let's show the tower. That's the result of the first strike. The second strike is here. And the final strike is here. I organize this file like That's the strike on the wall. Strike on the left tower, this one, and the strike on the right tower, this one here. That's the result. We are going to render this in Karma. Let's see now how I construct the rigid bar for the tower and make the demolition using the spinning rocks colliding with this geometry. Let's hide the geometry. Let's see the result here. The result, there's a low poly result and a high poly result here. Let's see, the low poly is much better to see in the viewport. That's the result. Now let's see from the beginning what I did. I import all the towers and walls, and here I separate which tower and walls I need to make the fracture to make the simulation. And the other side, we don't need to fracture this. For example, here, these 4 walls and these 4 towers, we don't need to fracture because we don't have simulation here. Just the center, 2 walls here. Just these 2 walls, 2 towers and a wall we need to fracture. We separate here a left tower, a right tower and a wall. We need to fracture this. Delete the other attributes we don't need. Delete all the groups we don't need and separate here. First, just fracture the wall. Just disable here. I create a material fracture wall with 3 layers of the fracture. Apply RBD pack and save the result here, the first frame. That's the result. The fracture wall. Let's see this with the explosion. That's the result of the fracture of the wall. Now let's see the result of the left tower and the right tower. Left tower, I just split just the walls from the window frame made of bricks. Create again. Let's disable here. Create again. Material fracture for both, RBD packed for both, and cache the result here. Let's see the result and see with the exploded view. That's the RBD unpacked with exploded view. Now let's see the right tower with fracturing both for the wall part and the window part. Let's see the save result here. Yes, it's working. After that, we merge all these caches, create an RBD unpacked with an enforce unique name here, and then we need to make the bottom fixed with static without any animation. First, we select create a box, group the bottom points, create all the colors black, and the color static should be red. Create a configure RBD configure static parts. Here we activate all the parts except the red parts. The static pose here should be deactivated. Create a constraint from rules. Constraint properties here, strength around 100,000, and RBD bullet solver. The collider are the three rocks and the wall at sides. Just these walls here. We don't need all these towers to collide because we can see at the camera. That's the collider, the three rocks and these walls. In the RBD bullet solver, let's dive inside. There's no difference here, just the full RBD solver. We cache this. Just cache the points instead of caching the geometry. It's much better to save just the point positions and orients because the cache was lightweight in the files. And the transform piece for the fracture. Here we use the transform piece. We can switch just for the low resolution version, the camera here, or the high resolution here, which will be rendered. Compute velocity after that, and create two checkpoints here. One for visualization and another for render. The same we can do here at the low resolution version, transform pieces and compute velocity. That's the result of the transforming piece. Now we are going to see the tower smoke setup. First here we import the high resolution explosion, make a debris source, and cache that to visualize the viewport. That's the result of the debris source. In that point we are going to emit some smoke. After the cache we clip the below. We don't need anything below the ground. We don't need anything back. We don't need this area here because it's behind the camera in the viewport. Create some density based on the luminance of the point. Create the pyro source and rasterize that. Create a smoke solver, pyro smoke solver, with some adjustment here in the shape, turbulence and disturbance. The voxel size should be the same from the volume rasterize. The boundaries should be limited because we don't need boundaries outside the camera. That's the bound. And cache the smoke. Let's see the result from the camera. Let's see with tower. Better check with the low resolution tower. We can change here. If you need to see the low resolution version of the geometry, we can disable here. That's this control. That's the result of the smoke emanating from the bristers. Now we can see the clouds at the sky. For that we just imported the camera. You use the QLib here to import the camera and make a plane for that camera. Create a plane for the start view position and the end view position. Merge both of the planes. Create a convex hole. Create a bounding, align it for that convex hole. Peak a little bit to expand. Using the matrix here from the bound, X-form, just to reverse the alignment to the world. Convert that to VDB. VDB from polygons, convert that for density VDB. Apply the noise VDB, noise fog. Activate to expand the voxels. Convert back this to volume. Apply some volume operations here, cloud noise. To make more off like a cloud. Convert this back to VDB density. We are going to copy this attribute here, xform, the matrix. Promote the matrix from the tail to point. And make a transform here. Move back to original position. Here. Using match size. That's the result of the cloud. There's no cloud animation, just the static cloud on the sky. This is the bottom layer. The same setup here is the top layer. The both clouds. For the rendering, we are going to use these nodes here. These nodes here just a reference for the output of each effect node. For example, the rock geometry render are just the 3 rocks imported for the setup here. All the other render nodes are just the import of the setup process here. We'll create a loop network and organize each one of these networks just one pass. For example, this is the first pass. These two are the cloud. Here are the castle beauty, castle shadow mate here, castle emission, and castle smoke. Here for the clouds, just import the cloud B. Create some material, karma cloud, just a power shader with some density scale, just that. Assign the material to the density here. Import our camera. Let's see the camera view. Create some distance light, intensity 10. Another distant light bounce. Using this cache motion blur here with the cache current frame only. And then create a karma render node. Let's see the result of the karma. That's the result of the bottom layer. Now let's see the result of the top layer. Just import the cloud's top. The same shaders assigned to the cloud. Import the camera. The same light setup. Cache motion blur node and karma render node. That's the result of the bottom, the top layer of clouds. Now let's see the other passes and let the castle beauty for the end. Here, the castle smoke are just the rocks. Smoke rocks here. The 3 strikes. The tower smoke. And the tower itself to make the phantom mask, phantom mate. Merge the 3. We can see here the smoke from the tower, smoke from the strike rocks. Import the camera. Let's see from the camera. Create a material library, assign the materials. Let's see what is inside this material library. Shader for the rock. Just to unify the noise with the Material X standard. The Karma wall, right, we are going to use the displacement and texture. The texture of the wall is this. Let's load this, the texture. That's the base color. We're going for displacement, the height, and the roughness. The rock smoke are just a pyro shader with a enable fire, high intensity fire like 250, and a high density scale around 7 with a dark smoke. Create some R lights here with this intensity, 2 dome lights with an AGR, cache motion blur, and the Karma rendering. Let's see the result here. That's the result of the rendering of these passes, the smoke and the rock trails. Let's see the result of the castle emission. We're just imported the trails, smoke trails, smoke geometry. Here, the smoke trails, we don't need the primary visibility. At the smoke, the tower, the castle geometry, we need to change the dicing quality around 0.1. Import the camera. Here, just the same materials, the rock smoke, wall emission. For the wall emission, we don't need any texture in the diffuse, just in the displacement. Cache motion blur with the cache current frame only, and another Karma render here. Let's see the result. Here the castle emission. Now let's see the castle maze shadow. Import the trails. Import the rock geometry. Import the tower again. Merge back. The same camera. Apply the same materials. With the same lights. Using cache motion blur. At the Karma node here, we are going to use some AOVs, like the shadow with the source name holdouts, shadow, and CDL. Let's see the result of the shadow mate. That's the result of the shadow AOVs. Now let's see the castle build. Just import the castle. Actually, here we need to change to the right resolution. Let's go back here. Change that control here to right resolution RBD. Go back to the LAP network. Import the castle. We prune some curve here, I think is the point below the castle. Enable the velocity blur. Import the same camera. Using the Karma physical sky here. The same 3 lights here, R light and 2 dome lights. Apply the same material. Karma wall. With the diffuse. Color correction. Multiply the color correction to diffuse with ambient occlusion with some color correction and apply to the base color of the Material X surface. Apply the roughness, change some luminance, and apply the roughness to specular roughness. Import the height map, apply to the displacement with low scale, assigning the material to the castle, using camera motion blur. Using Karma render, we need some AOVs like ambient occlusion, direct glossy reflection, indirect glossy reflection, indirect diffuse and shadow. And some shadow here. Let's see the result of the render. That's the result of the castle build. Let's see some passes here. Ambient occlusion, direct diffuse unshadowed, direct glossiness, indirect glossy reflection. I think I almost is invisible. Shadow. That's it for the renders. Let's check now the Nuke composite. Now let's see inside the Nuke, see how I created the compositing from the beginning. Here I just imported the castle pass. I shuffle a channel just to extract the diffuse without shadow. And I color graded this channel. Make some correction here. I shuffle another pass, the shadow inside the castle building. I invert the shuffle. Multiply with the build without shadows. And create another shuffle here, just to extract the reflection glossiness. Make some color correction here to increase the contrast. And I merge with the castle beauty and shadow. Make some color correction here to make more bluish tone. And I copy the alpha back. I multiply this with the shadow of the contact. This without shadow. This with the shadow. The shadow here just for the contact of their fire rocks at the walls and the tower. I import the shadow, shuffle, invert, reformat for full AD, and make some color correction here to increase the contrast, and multiply with the build of the castle. And I import the emission, shuffle the channel just to extract the emission from reflection, color correct a little bit, reformat, color correct to increase the contrast, the highlights. I apply the blur just to avoid the sharpness of the reflections, the emission, and I copy the alpha back, and I merge with plus operation with the beauty. Then I import the rocks, the smoke in the rocks. That's the pass, the cool pass. Inside this pass, there's a pass called AOV Fire. I use the fire to increase the glow areas in the hot spot. Then I shuffle this. Let's see first the smoke. Unpre multiplied. Apply some grade correction here. A color correction to increase the contrast and the luminance. Apply the pre-multiply back. Apply a color grade. And I merge with this glow operation here. Shuffle to AOV Fire. Color correct. Make some small glow. And I merge with the original smoke. And I create two merges. First merge of the smoke using plus operation, and another merge using over to increase the definition of smoke here. And I import some passes of clouds. This is the bottom pass. This is the top pass. Color correction the bottom. Merge with the top. Create a constant color here. Shift a little bit to desaturate. And then merge back with the clouds. Color grade to make the skies bluish. A little bit of color correction to increase the contrast and gamma. And I merge back with the castle. Apply some LUT operations here, vector field. And I merge with the operation plus with another glow here. High spots from the fire, and I plus here. Then I make the rotoscoping. To make the vignette, let's fix this. Invert the alpha. Make some blur. Before the vignette, I apply some grade here. And apply another grade with the vignette mask, just to make the more cinematic, and the borders try to make a contrast. And I create another pass of lens dust using some roto in this spotty area here. This is the alpha. This is the alpha with blur. Invert the mask. And I import this dust here. Color correct a little bit. Create some grade to change the color. Color correct again. And merge with the composite. You can see here some lens dust in this area for this rock fire here, and another dust here for the second strike for this area here. You can see here the lens dust, and the third one for the final strike in this area here. You can see here the lens dust for the final strike, and apply a lens distortion to make it more interesting, a crop, and save. That's the result. Let's play here. Alright, that's it for this tutorial. I hope you learned something useful and got inspired to create your own destruction shots. If you enjoyed this breakdown, don't forget to like the video and subscribe to the channel for more Houdini and VFX content. And if you want to study the scene in detail, the full project file is available in the description. Thanks for watching, this is Wanderson from MATLAB VFX, see you in the next one.